Combined gas law. Combined gas law brings together both the Boyle's law and the Charles law. We said in our previous lessons that gas laws are obtained after studying the relationships between various physical properties of gases. If you remember, these properties of gases includes pressure, temperature, volume, and mass. In this video, we will derive the expression for the combined gas law and solve some problems or questions using the derived law. My name is Fred Arapto from Teacher.co.ke, and let's get started. As we have already said, combined gas law is derived from the two gas laws, that is, Boyle's law and Charles' law. If you cannot distinguish between the two or remember which is which, then kindly check our previous video lessons. The links are shown below, or you can also check on our website page teacher.co.ke/video lessons, and then move to chemistry and then select the gas law topics. To start deriving, let's state the two laws. Let's start with the Boyle's law. So Boyle's law states that for a fixed mass of a gas, the volume is inversely proportional to its pressure as long as the temperature is kept constant. So V is inversely proportional to P. Whereas the Charles law states that volume is directly proportional to temperature as long as the pressure is kept constant. So V is directly proportional to T. So to combine the two laws, we will start with the Charles law. We have said that V is directly proportional to T. So to bring in the combined gas law, we can simply say that V is directly proportional to T and inversely proportional to P. To remove the proportionality, we will have to introduce an equal sign and a constant. So our V equals KT over P. Rearranging the above equation, we will have K is equals to PV over T. We simply multiplied both sides by P over T and then remained with K on one side. So this expression simply means that PV over T is a constant. So if we have a fixed mass of a gas and its volume changes from V1 to V2 and its pressure also from P1 to P2 and its temperature from T1 to T2, the three values can be expressed as P1 V1 over T1 equals to P2 V2 over T2. Let's now have some examples to help us see how we can be able to apply the combined gas law to solve some numerical problems. A given mass of a gas occupies 20 cubic centimeters at 25 degrees Celsius and 670 millimeters of mercury pressure. Find out the volume it will occupy at the following pairs of values. A. 10 degrees Celsius and 335 millimeters of mercury. B. 0 degrees Celsius and 760 millimeters of mercury. You can pause the video and try out this particular question. Then you can then resume and play back to confirm your answers. Solutions. A. Before starting to calculate, let's extract the values as we have already said, or we have always said. A given mass of a gas occupies 20 cubic centimeters. So 20 cubic centimeters is our V1. So we write it down, V1. And if we continue the question at 25 degrees Celsius, so 25 degrees Celsius becomes our T1, and we convert it to Kelvin scale simply by adding 273, and we get 298 Kelvin. If we continue from the statement, and 670 millimeters of mercury, so that is our pressure 1, P1. Let's write it, 670 millimeters of mercury. Now we are told that the 10 degrees and 335 millimeters of mercury, if you can check, this is T1 and this is T2 and this is P2. So we are searching for V2. So we can have V2 equals whatever we don't know. Let's write it somewhere there. And then T2 is 10 degrees Celsius. Converting it to Kelvin scale, we add 273 to give us 283 Kelvin. And then P2 is 335 millimeters of mercury. So from our combined gas law, we have said that P1 V1 over T1 equals to P2 V2 over T2. If we substitute, we'll have 670 times 20 divided by 298 equals 336 times V2, which we don't know, divided by 283. So if we work out to make V2 the subject, we will have V2 equals 670 times 20 times 283, all of them divided by 298 by 335. So if you work out this in your calculator, you will have your answer as 38 cubic centimeters. The second part, B, we have already our first pairs of values, P1, V1, and T1, so we'll remember them. Let's just express our second pairs of values. So our V2, we don't know. Our T2 is 273 Kelvin, and our P2 is 760 millimeters of mercury. So just as the way we did in our part A of the question, let's repeat the same in our part B of the question. So P1 V1 over T1 equals to P2 V2 over T2 according to the combined gas law. So substituting our values, we are going to have 670 times 20 over 298 equals 760 by 72 divided by 273. If you rearrange or make V2 the subject, we will have V2 equals 670 times 20 times 273, everything divided by 298 times 760. So if you calculate this using your calculator, your answer comes to 16 cubic centimeters. So that is how to apply the combined gas laws. So before we finish on the topic, kindly check on the standard conditions for temperature and pressure in the next lesson before we wind up on diffusion by looking at the Graham's law. If this video lesson is helpful, then don't forget to like it, plus subscribe to our YouTube channel and also click on the notification bell to be notified of new videos when we release them.